I decided to have another look at this A600 a couple of days ago because there were some things I wanted to investigate and have a look into, and a couple of suggestions that people had made. So I switched it on as normal, and as you can probably see, workbench started up and everything as normal, but it's the wrong colour, and I've realised that basically the red is missing from the image. So I've done the obvious things, checking like the cables, make sure they're plugged in. I've got this conversion board down on the bench, which I'll show in a minute. Check the VGA cable, that was the first obvious thing to try. Check the video port on the back of the Amiga. Made sure that the wires on this crappy mackled together thing are still connected, which they are. Did all that. I've tried the menu on the monitor just to make sure the actual monitor's doing what it should, and you can see we've got white text on the screen, so we're clearly getting a full RGB with respect to the monitor. So the next thing was perhaps to try plugging in another system to this conversion board, but rather than digging the A500 out, I decided to do something else instead. So on the conversion board, you can see here, hopefully we've got this set of wires, and that goes to this mackled together thing, and then we've got a red, green and blue wire here, and they actually do correspond to the red, green and blue video signal. So what I've done is take this connector out, remove the wires from this header, and switch the red and green around and see what happens on the screen. And basically by doing that, I've been able to diagnose and see that there is no signal coming through on the red wire at all, which means that it's not the conversion board, it's actually the signal coming from the Amiga. Another thing I could try, although I can't at this stage because I haven't repaired it yet, I could have tried the composite port on this, which is something I may do next. We'll see, and see if I get a signal out of that, because that will help me diagnose where the fault is. But there's definitely a problem on here with not getting any red out of it. I was also getting a whole load of interference on the screen, and that turned out I've got this wire here, which is not a shielded wire anyway. That was underneath the power connector there, and it was wrapped round such that it was not right against this little inductor down here on the board. And it certainly seems, if I say put the green wire there, or the black wire, you'll be able to see interference on the screen. That's quite bad there now. I don't know if that's showing on the camera, but you get like a moving diagonal pattern. So I thought that was perhaps part of the fault at first, but it just turns out that it was this little guy down here. And I'll just demonstrate what I did here with these wires. So I'm just going to turn off the Amiga. I suppose I should pull the power to the board as well. These pins are a little loose on this now. So you can remove these wires by just using a pair of tweezers and pressing down on here, this little bits that stick up, and latch these into these holes. And I've pushed them down, probably pushed them a bit too far now because they keep coming out, but once they're out, well, they've latched again now, you can tweak the little bit of metal so that it latches again. So I'm just going to remove the red and the green from there, and I'm going to just plug that in on its own with just the blue. Oh, another thing I did do before I was starting to switch all these red, green and blue cables around to test the output, I pressed the menu button on this converter board, which at the moment seems to have dropped out of English language setting, which is a little bit annoying. As you can see though, we've got white text on the screen and white graphics on the screen, so this board is clearly sending a red, green and blue signal to the VGA monitor, so at least know the output side of this board is working. And so this switching of the wires will now test the input side. And at the moment you can see I've just got a blue on the screen, only the blue signal. So I'm going to power everything back off, and I'm just going to add the green back in, but I'm going to put that where the red was. The red wire is still disconnected, and we'll power back on again. As you can see, we're getting a similar amount of blue and green signal from the Amiga, because the background of the workbench is normally grey, but because the green is plugged into the red input, we're getting a mix of red and blue, which is given as this magenta colour. So that confirms that the red input pin to the conversion board is working, and so the conversion board is doing what it should do. And similarly, I can put the green back as it was without the red connected. So I'm going to power up again. I didn't turn the power off on the conversion board then, but I don't think that's going to be an issue, to be honest. And we're back to this sort of a turquoisey colour, which is a mix of the blue and the green. So you can see having the red connected from the Amiga is making no difference, so we're getting nothing out of the red whatsoever. And there's also these 3 variable resistors on here, and they let you tweak the red, green and blue values. Obviously it's not an issue to do with that, because by swapping those wires around we've proven that. I was under the impression that because I've got this oscillator missing down here, which is this rusted up one that had fallen off, and I've got a replacement for that which can be fitted at some point, I was under the impression that because of that the composite output and the RF modulator wouldn't work. And I'm not really sure why I came to that conclusion, which is completely incorrect. And more to the point, I wasn't sure why, if that was the case, that I thought it would only affect those and not the RGB output on the video port. If that was going to affect anything, then it would affect all of the video outputs, and that's something that can be seen on the diagram here. So we've got this Power Goodies circuit here. There's the little oscillator that's missing is down here on the diagram, and that feeds up into this Sony video encoder chip, and all of the outputs come from that. Now obviously RGB has been working, currently it's just G and B with no R, but that clearly is still working without this oscillator in place. So I'm puzzled to understand exactly what's going on here and what the purpose of this is if that's missing, but that'll be perhaps something else to look into at another point. I've just generally spent a bit more time looking around on this diagram. I've noticed these little cubes up here in this delay line, they actually relate to these components down here on the board. I did wonder what they were for. Now on the board there's quite a lot of the video circuitry, obviously up towards near where the video port is. Around this area here we've got the Denise chip there, and then there's obviously traces that are going to come over here. We've got the Sony chip over there, other supporting components around it, and there's also various resistors and transistors dotted about, and they're also all to do with the video circuitry. I was initially wondering if these capacitors could be a problem. Obviously they are a problem because they're not in very good shape, but it turns out that they're not actually in the path of the video signal itself, or at least not directly in the path of the video signal. Where there are some electrolytic capacitors in the video circuitry is one on the colour composite output, which you can see here. There's also one in the path of the modulator, which also taps off of the colour composite output, and then there's 2 more here that go to the modulator itself. So you've got one going to the +5 volts, and then another one here which the audio passes through. I have been thinking, as I've took the modulator off and I've got no intentions of replacing it, is it actually worth putting these 3 back on at all, these 3 capacitors that go to the modulator? I would say this one here maybe would need to stay on them. Again, I don't really know, I don't fully understand the implications of how the circuit works, so, but I would have certainly thought that these 2 could be left off when I do the recapping, but we'll see. So I've got the Amiga switched on again, and I'm on the RGB output at the moment, which, as you can see, there's no red in the RGB output. Now if I just switch to the composite output, which I now know works, you can see on here we're actually getting colour, full RGB colour, which is interesting because that will help diagnose whereabouts on the circuit the problem is. The issue with the capacitor that I was mentioning, if I just sort of gently press on this capacitor and nudge it a little bit, you get sort of glitches on the screen, and that only seems to affect the composite output for some reason. If I go back to the RGB, I'm doing that now, and there's nothing happening at all with that, which is a bit strange really. I've got to be honest, this video has become quite frustrating to do because I've had to keep stopping and starting, and every time I come back and start to record another bit I realise that something in the previous bit that I've said is completely wrong, or I've completely missed something out. So it's turned into a bit of a nightmare. With this video power circuit, what I've realised is this capacitor down here, this C460, that's actually feeding into the Sony video encoder chip. This U12 here is actually that. This is another thing with the schematic diagrams it's really easy to get caught out on, is to not assume that just because you've seen a component or a chip in one place of the diagram that's the only place it will appear, and it can appear in multiple places. So on this diagram, which has got more of the video circuitry on, you've obviously got this bigger blown up version of U12, and that's just dealing with all of the video signal side of things. But then we've got this one here which is more specific to the power, so it's only showing the power related pins, and it's quite common on these diagrams. That's something I also noticed when I was looking at the part of the circuitry to do with the Gale chip. Nothing to do with this, I was just looking through the diagrams, just trying to get a feel for what everything is. And that appears in multiple places, and there's different aspects of it shown on different areas of the diagram, so it's worth bearing that in mind. So you can see down here C460, which I've just been fiddling with, that feeds into here, and there's something called IREF, and on the datasheet for this component, for this video encoder, that actually goes into a block diagram which shows a regulator, so it's clearly some kind of power feed, power regulator, or some kind of reference value for this video chip. And there's also another one here called VREF. I'm not quite sure what this stands for. The datasheet I've got seems to all be in Chinese or something, so I have no idea. But it may be that nudging that capacitor only affects the composite, because it may be that this IREF only feeds power for the composite side of the output, maybe VREF is more for the RGB side. I don't know, I'm just speculating, but that would make some degree of sense. But either way, none of this has really got anything to do with the RGB problem. So going back to this main overview of the video circuitry, you can see here the first place we get any kind of red, green and blue split out is from the Denise chip. And these are 4-bit RGB outputs. And these are feeding into these chips here. And then from there, they're going over to some other components, which basically, I think this is acting as a digital to analog converter. So we're getting a 4-bit binary output from here, and then that's getting converted into a voltage to represent that output level. And these are then getting fed into the Sony video encoder chip. And we've got 3 of these, one set for the red, one set for the green, and then one set for the blue. And then on the other side of the video encoder chip, we've got the same again. We've got a red, green and blue output that goes through some more circuitry. There's some transistors and resistors and whatnot as part of this circuit, and then that goes off to the actual video output port on the back of the Amiga. And then down at the bottom here we've got our composite output, which is obviously a combination of all 3 of these. So what that tells us is that we're obviously going to be getting the red, green and the blue coming into the encoder chip. They have to be working for us to get a colour output at this stage here. So that means that all of this over here is obviously working. We also know that the green part's working and that the blue part's working. It's just the red that we're unsure of. So it could be that the components in this area here could be a problem, but it could still be, even though we're getting the colour output from this encoder chip on the composite port, that's not to say that there isn't potentially still a fault in here with respect to the red, green and blue outputs. So simply by plugging the composite in and seeing if we get an output from there, we've been able to eliminate all of this part of the circuit as being a possible problem, and we're just left basically with either this chip or something in this box here. So that's really where we need to start looking next. So I've spent quite a bit of time messing around now, and the noise you can hear in the background is the oscilloscope, as I've set that up and spent a little while trying to figure out how to use that again, because I've not used it for so long. It's not something I've really used much of anyway, and I've been able to use that to see what's going on here and figure out where the fault is. So I'm just going to start by putting the probe on the blue, and then you should see on the oscilloscope screen we've got a bit of a signal showing up there. There's a little bit of movement on it as well, and not just the juddering around, but you'll see like a line flying across the top of the screen and keep disappearing and coming back, and I'll sort of get onto what that is in a bit. You might already know what it is, but that's basically showing the signal from the blue wire, or a representation of it. If we move over to the green, it gets a bit rolly sometimes, it doesn't always lock. There we go. And again we've got a similar thing. Go over to the red, and we basically don't get much of anything. There's a slight increase in the intensity of the signal there. It moves up a little bit, which suggests there's some voltage getting through. So if I increase the sensitivity, you can see the signal much closer, and it's really just quite random and noisy looking, so it's not anything like what we should be getting. If I go back onto, say, the green again, there's a clearly defined signal there. So that really just shows what we already know. There's no red signal coming out of the port at the back. So now there's really a choice of where to take a reading from. I mean, I can go straight to the video chip and see if there's any signal coming out of that. There are basically, along this bottom edge here, I've got pins 2, 3 and 4. They're where the RGB goes into the chip. We know that's working because we're getting the composite video signal out, so it's not going to be a problem there. And then we've got pins 23, 22 and 21, which are 2nd, 3rd and 4th from this top left position here. They're the RGB output pins. So we could probe there, although they are very fiddly to get in, and to be honest these are very dull and need a good, well, they need reflowing really. They're not very good at all. So I've tried probing these. You can, but it's hard to get a good signal out of those. So there's a number of components on the top here that have got accessible solder points that we could test from. The most logical place I think is testing these transistors here. We've got red, green and blue respectively. Each of them deals with a different colour channel, and we've got the collector at the bottom. That's the single pin on its own, and that's what's fed with power to power the transistor. We've got the emitter on the top left, which will be the output of the transistor, and we've got the base at the top right, and that will be what takes the input from the video circuit, and then that will either be amplified or whatever the transistor is doing with that. So the logical place to test first is the base, to see if a signal is actually getting to the transistor first, and that will then tell us if our video chip is working as well. So I'm going to start off by testing the inputs of the green channel, which is the base, just so that I know what's going on. I've had to adjust the position on the scope slightly because it was going off the top of the screen, and you can clearly see we've got a signal there. And if we test the other side, the other leg, that's the emitter, again we're getting a similar looking signal. So that shows us what we already know, that the green is working, but that gives us some idea of what the other signals should look like, because they should be very similar. So if we now go to the red, and I'm just going to latch onto the base there, and again we can see a very similar looking signal. And what that now tells us is that the red output from the encoder chip, the RGB encoder chip, is actually working. So we've now eliminated that from the list of possible issues. If we now go to the other side and go to the emitter pin on the transistor, and you'll see we get a similar result. We're not getting a proper signal, it's just a slightly fatter line because there's a lot of noise there by the looks of it. So that basically says to us that this transistor is probably not working for some reason. If we just now also, we can squeeze in here to get to the blue, and you'll see again a similar looking image to before, and I should be able to just get onto the emitter side, and again it's similar. It's not exactly the same, but it's similar enough that we know that it's working. I've lost my ground connection, so that's probably why the signal started to look a bit funny there. So one more thing to do here is to just test that the collector's actually getting power to it, because if the collector's not getting power to it, then we're not going to get anything, because, well, the transistor needs power to operate. I'm just going to try and squeeze the multimeter onto the screen at the same time here as well. So I'm just grounding that as I've done with the scope probe, and then I'm just going to put the positive on the green channels transistor, and you can see we're getting 4.93 volts going into that, and for the red channel again 4.93 volts. So we're getting power to it, we're getting a signal to it, we're just not getting an output. So that tells us that this transistor's died, or there's something wrong. Could be a connectivity issue, but I mean, it might be worth trying to reflow it actually first before trying to do anything else. So I can give that a go, but it's either that or that transistor's died. So I've just gone on to the outputs on the back of the Amiga here, and I'm just on the scope. I've just altered the screen setup a bit here, and I found it quite interesting to see what all the different lines were, what they're all representing, because this is basically a sort of a linear representation of each channel of red, green and blue that creates the image on the monitor. Obviously we're only able to look at one channel at a time. I'm currently on the blue, and what this line is that you can see at the top, and there's also two or three more down here, what you're actually seeing is the video signal changing as the disk insert animation is happening on the Amiga's startup screen. And basically you've got time running across this way, so these will be, this first part of the screen here will be lines near the top of the screen, and then as we go further along that will be lines further down the screen. And what you're seeing across the scope vertically is different intensity levels at that point in time. So with our disk insertion here, this line going across the top, this is a fairly high intensity line. Well, it's probably full intensity, it's right at the top, so that's probably going to be full, well, we're on blue at the minute, so that'll be a full level of green. And I know that that is white by looking at the screen over here, so we're seeing that basically going into the drive. That's what that is there, and that's white. And the reason these other lines down here are further towards the centre of the scope is because if you look on the screen, when the animation starts, they're further towards the middle of the screen over there. They're lower down because they're not such high intensity. The white label is full on, well, it's a full on red, green and blue. Obviously again we're only looking at the blue, so there's going to be a full on blue component there, but the shutters are grey, so we're only going to see a lesser of an intensity and further along, and that's what you're seeing there. And there'll also be some of that will be probably the actual disc itself. And I think these four sort of semi-faded bits here may be the text on the screen there. And there's also this diagonally line on the scope, and again I think that's part of the little tick sign, the multicoloured tick. Another thing I've noticed is we've got these two lines here. We've got this line along the bottom. I'm not sure if there's some kind of, there's probably some kind of synchronization pulses or something in here, so that might not actually be anything to do with the colour intensity. I could be wrong there. Then we've got this very noticeable line here across the middle. If I go to the green, it's there again on that. In fact, this is better seen off of the transistors, because I need to be able to show the red to demonstrate this. So I'm on the green there, and again we've got this sort of base line across the bottom, then we've got this second line part way up, and if we go to the red we've got the same again, but this second line is even further up the screen. If we go to the blue, it's even further up again. So the red and the blue, the lines very high up across the whole width of the screen, And what that basically is, because we've got this purple background, so that's a mix of the red and the blue giving us the purple, and that's been shown on the scope. So I thought one other thing that was worth doing, a quick look on the diagram, was actually just to check continuity, because I was saying it could be a bad joint, so I could try and reflow it. Don't think it's going to make any difference, to be honest. But what I've thought is I can just test the continuity from the transistor's emitter, which again, if I just quickly go on to here, so that's the transistor, that would be the emitter, and that goes onto a resistor leg to ground before it goes off through another resistor through to the port on the back. So we could test continuity between the emitter and that first leg of the transistor, which is R233A. Unfortunately, R233A is actually on the other side of the board in a completely different place, so that's going to make testing that a pain in the backside, but we can have a go. It's actually, if you look on the back of the video port, it's actually that one there, 233A. We've also got 233B, which is, I think that's the green. I'm not sure where the other one is, it might be on the other side, but that's the one that needs to be tested. And I get a sort of a falling value from about 7 or 8 ohms, and then it gradually drops down to about 1. And I've tried that on the green as well, and I get the same, so there's clearly continuity there. So it's very likely it's just a transistor that's died, and then reflowing is pretty much a waste of time. So that transistor is a 2N3904 NPN type transistor, and there's quite a few of them on the board. I think there's at least 6 used on the video circuitry, and then there's some dotted around in other places. I did actually spot a transistor and thought, I wonder if I could just pinch that off the board just for testing purposes until I can get hold of some. That's this one up here. But unfortunately, that one's part of the serial port, and as we've had this problem over here, that's one of the paths that I was worried about there having perhaps been power gone through, so I'd prefer not to use that one. There is, however, some more over here, and this is to do with the reset circuitry when you do your control Amiga, and also just when the machine's very first switched on. We've got a 555 timer down here, and I've actually got another A600, and the fault that was on that, on the listing that I bought it from, said something about, I think it comes up with a black screen, and I think the black screen is very commonly this cap fails and then the reset circuit stays stuck in reset mode, so the Amiga just doesn't start up. So I'm hoping with that, simply swapping out that cap will resolve that. I'd imagine it's that one there by the looks of things. So there's 2 transistors here, and this Q622 is part of that keyboard reset circuitry. So for the time being I could pinch that, because losing the control Amiga isn't the end of the world for the moment. I mean, we're on, I think, part 9 or 10 now, and we still haven't had a keyboard plugged in yet, so it's not like we need it, is it? So I might remove the red channel transistor, see if I can get this one off intact, and then solder that in over there and try the video feed again just to see, because that just proves it then at least. And then I can order a bunch of these in and perhaps replace all those 3 on the video so they've all been done, and well, take it from there really. So I'm just going to see if I can get this off with the iron. If I get enough heat into it, it should come off with the iron. Don't fancy using hot air around here with the capacitors, to be honest. I'm not going to flux it up at the moment because all this is going to be cleaned up anyway. And I did say flux, not the other alternative, although that's still a possibility yet. It's not coming away, I need the other tweezers. It's got it. Tiny little thing. I won't leave it on the board. That's only asking for trouble. So I'm just going to put a spot of flux on the braid, I think, just to help pick the solder up and then try and clean this up a bit. Spot of IPA. This is a bit where you realise it's the wrong one you've took off. I'm just going to try and remove the other one with hot air. Just give it a go. See if it will come off a little easier with that. Right, to about 350. I could probably do with a smaller nozzle than this. Straight off, no problems. So now it's going to be a matter of seeing if I can solder this in place on here, which could be interesting with how small this thing is. I mean, if I'm buying some new transistors anyway, I'm probably going to redo this, but it's just really just want to prove the point, really, see if I've diagnosed the problem and if that's it. I'm just going to try and hold this down, and it moved. It moved badly. It's definitely been on the booze, that one. Let's try and see if I can get some on the other pins, the legs, should I say. It's not really the ideal bit for this at all. In fact, it's completely the wrong bit for this. As I say, it's just to see what's what, and then all of this area is going to get cleared of all the caps anyway, so any other smaller work like these components can be done, and then cleaning up can be done, and then the caps put back on. So I don't think it's particularly the straightest that it's been put on, and it's a bit blobby, but you can certainly see the difference in the shininess of the joints between that and all the other components. Okay, so the bench is a bit of a mess yet again, and it's time to see if this has worked. We've got a white screen, that's a good sign. There we go, we've got colour. However, we're still on the composite input. And that's the RGB. So that's clearly fixed the problem. So that transistor had definitely died, and now we've replaced it with another one, and it's working fine. So this has been a pretty long video for the simple sake of just replacing one transistor, but obviously there's a process to go through to try and figure out what the fault is and track down exactly where it is and what needs to be done to resolve it. It's also been interesting looking through the schematic diagram again and getting a bit better understanding of how all of this works. Now I can get back on with what I was going to do in the first place, if I could remember what it was.